We are working on identify single rotation or reflection, composing transforms, shapes discovery, and composition of transformations, shapes. Let's go ahead and get started. So we are identifying a single rotation or reflection. It's real important that we actually test some of the values to make sure that it is what it should be. This one looks pretty straightforward. We can kind of see that if I cut through with the y equals negative x line, that it looks like it's a reflection on the other side. So let's go ahead and it is a reflection over the y equals negative x line. Not too bad on that one. Let's do another one that's a little bit more difficult. Some of these can be tricky. And that's the animation of how it reflects over. Let's see. Let's get rid of that. All right. Yeah, this is what we're talking about. Got to be careful for something like this. You may get fooled into thinking it's a reflection, but just be careful. Do a little test point. So it looks like, I would say, a rotation of 180 degrees, but when you have a rotation, just be careful that everything matches. So 180 degrees rotation has the form x comma y, and it turns into for 180 degree rotation negative x comma negative y. So we just want to test a point here and make sure that it fits that form. So I'll go ahead and test that point right there. Should be clear that that's kind of the back corner. Try to pick a point you can identify. Another one would be kind of that point to identify. So this one or this one are the ones I would choose. I can recognize this one a little bit easier. This is the point 3, 1. So if it is a rotation of 180 degrees, then it should turn into negative 3, negative 1. And let's check. Negative 3 for x, negative 1 for y. So that does check out. It's a rotation of 180 degrees. So the key here is to make sure that it fits one of the forms, and counterclockwise or clockwise doesn't matter. So test a point just to be sure. Okay. Let's try the next problem set, composing transforms. It's a shapes discovery, okay? Composing meaning more than one transformation on this, and we're dealing with a shape this time. Okay, so let's go ahead and get the old work out of the way, and here we go. So if I were to do this, my initial thought is I can see that it goes from a bigger shape, because these don't have primes or the little apostrophes on them, and it turns into this shape. And notice they do have the little primes or apostrophes. So this is our original, this is our image. And I can see it gets smaller, and so I'll just go ahead and look at one of the sides. So A to B turns into, let's see, it goes from 6 to 9. So that distance is 3. The new distance here on this tiny one is from 2 to 3. 2 to 3 turns into a 1. So what sort of dilation or scale factor changes 3 into 1? So we can even do it like a math problem if you want. 3 times what number equals 1? So if we divide both sides by 3, it turns out that x is equal to 1/3 in this case. And when I say x, I'm using that as my scale factor. So this is a dilation. So the first one I would do is a dilation of 1/3. And then I can kind of check the other ones if need be, but I'm pretty happy with the way that one looked. And so what would happen if we had a dilation of 1/3 going towards the origin, So this time I'll go ahead and let's change my color on this one. So we would want to look at a slope triangle and how it got to the origin. Okay, so that slope triangle, let's say 1, 2, 3, 4, 5, 6. So that's a 6 on the change in y, and 0 to 6 is a 6 also on the change in x. And if I had that scale factor, that 1/3 applied to it, then that 6 would change into, times 1/3 is 2. And same thing for that one. The other 6. 6 times 1/3 is 2. So that means it would, this corner right here lands at 2, 2 from the origin. So there's 1, 2, there's 1, 2. So that's where that A point is. And so notice that to get where I need to, let's change color one more time. To get where I need to here, I need to go up one spot. So this one to this one is up 1. So that's a up by 1, up 1. Up 1 is a change in y in the positive direction, transform. So then I would transform a up by 1, so that'd be a 0 for x change and a 1 for y change. So this is a composition of the original, so whatever that shape is. So here's my shape. And first we're going to dilate it by 1/3, and then I'm going to transform by 0, 1. And let's go ahead and fill that in. So I did first a dilation of 1/3. So let's see. And trying to change to a mouse. See, escape does it. Yes, escape did it. Good. So it's a dilation centered at the origin with a scale factor of 1/3, followed by a translation. This one was up 1 unit. And since this is a discovery type problem, then that means it will kind of give you some help along the way if you get something wrong, and you'll see how it moves. But there's my dilation, lands where I wanted it to, and then it moves it up 1, and that links in together. Submit answer.